Alright. Y equals x power of a half and 2x minus 1. So u equals x power of a half. We identify this as a product rule because it's one part multiplied by another part, a green part multiplied by a yellow part. That to us indicates that we could use a product rule, okay? I can show you another way of doing it in a second, which is probably just as handy, alright? But for argument's sake, it actually tells us we have to use the product rule, doesn't it? So I suppose that is the only way to do it for this question. Alright, now the product rule is the y dx equals u dv dx plus v du dx. And that's stored in your maths tables, okay? Now, we're going to differentiate u, bring a half to the front, take 1 away from a half, okay? Now we get v, and v is 2x minus 1, and then dv dx, 2. Is that alright with you guys? Okie dokie. Now, let's put this in, and we get x power of a half. What's the v dx, lads? 2. And v, 2x minus 1 times the u dx. That's a half x to the power of minus a half. Okay, multiply this out. 2x to the power of a half. Now, how do you multiply 2x by a half? So 2x multiplied by a half, x to the minus a half. Anybody have any ideas there? 2 times a half? 1. Yep. X multiplied by x to the power minus a half. X power 1, x power minus a half. What do we get? Add the powers together. Okay. And then finally minus 1 multiplied by the whole thing is just minus. Okay. Does it have any specific criteria? It wants it as a single fraction, doesn't it? So that's I suppose a bit frustrating. Alright. What's 2x to the power of a half plus 1x to the power of a half? What'd you say? Yeah. 3x to the power of a half. Is that alright? Now what about this? 1 over 2x to the power of a half. Is that alright with you guys? Now, alright, I have to give them a common denominator, don't I? Can anybody tell me what is x to the power of a half? Would you be alright if I just went back and just turned them back into root x's? You don't have to, but I suppose I'll just do it that way. Alright. Who got this far? Okay. Now what can I do top and bottom to make this a single fraction? Put 2 root x on the bottom, then multiply by 2, and then add another root x. Now what's 2 times 3? 6. Root x by root x. So would everybody be happy with 6x minus 1 all over 2 root x? Who got that one anyway? I'm fire these days. You feeling okay? Okay. Question 6. This is a quotient rule. Reason why we know it's a quotient rule is we identify a variable, the letter is on the top, x is on the top, but there's also x's on the bottom. This means we've identified that we need to use the quotient rule. Okay? And the quotient rule is the following. The y dx is v to u dx minus u to v dx all over v squared. Is that okay with you guys? Now, u is equal to x, and then what do we have next? Differentiate, and what do we get? 1. And then v, then dv dx. Once we differentiate it, we kill with that. Now, 1 minus x squared du dx times 1 minus u x times dv dx all over v squared. Did most of you get that far? Okay. 1 minus x squared and then 2x squared and what do we get when we add them together? What's minus x squared plus 2x squared? Huh? Now, you sort of have to explain why this is a. You're going to have to explain why this is a positive number, no matter what. Okay? Now, first thing you can say is denominator is perfect square. What does that mean? Always positive, yeah? Everybody happy the denominator is always positive? Now, 1 plus x squared is always positive. Why? As x squared is always greater than equal to 0 for all x elements. Or, doesn't matter what value of x you put in, it's going to turn positive, and it's going to add on to 1, and it's also going to be positive. So it's positive no matter what. Is that okay? So you just give a quick 2-line explanation as to why it's bigger than 0 and you're good to go. Is that alright? Was it just the explanation at the end? 3 is right. 16. Oh. What have I done? 4, 6 and 16? Okay. Okay guys, so what do we get here? Ah? 3. Alright, the v dx minus 2. Use the quotient rule. Phi times the u dx minus u times the v dx. Always worth writing down the formula, by the way. Sometimes you get a temp mark, so just writing down the correct formula in its fullness, alright? I know that formula off by heart. I'm just doing it to show you that that's how you pick up marks, alright? Fill it in. That's u. And the v dx is minus 2, isn't it? I'll just put that there. Alright. I reckon the x's cancel, do they? What's a 3 minus 6x? And then minus by minus is plus 2. That's a plus 6x. And a plus 2. And what you get as your answer then? Anybody? 5 over. So 5 is the k value. We cool with that? Alright. Alright guys. Alright guys, we're going to do part 7 now. We're going to do what's called the chain rule. Believe it or not, you've been doing the chain rule all along, you just don't know it. Okay, so look at this. A really basic example was earlier. X to the power of sorry, we'll do it this one, right? X to the power 3. You guys all tell me to do the following, don't you? 3 to the front. Take 1 away from the power. So a chain of 3 x's now becomes a chain of 2 x's. Would you agree with that? Can everybody see that visual? A chain of 3 x's now becomes a chain of 2 x's. Now, the hidden part, which we never do, is, do you know the way you took away one of the chains? Yeah? You actually differentiate that part over here. But because we're always doing it with x, what happens when you differentiate x? You just get the number 1. So we've never felt the need to spell that out like that. Okay? Now, taking what I just showed you, okay, what can you tell me about this question here? It's very similar to what we just did. How many of them is there in a chain? How many of them is there? Would you agree there's 3 of them? Okay, there's 3 of them. So what happens when we bring the 3 to the front? Just goes there. What happens to the power? -1. And do you remember the hidden part I just told you about a second ago? You had 3, now you only have 2 of them. What did you do with the one you got rid of? Well, you're going to differentiate it. So what happens when you differentiate this? And your answer will become 3 times 3? 9. And that's your answer. Am I allowed to multiply in by the 9? Why not? You have to square before you multiply by 9, alright? Now, will you guys try 7 part 6 on your own? Okay? Yeah, find and leave it like that. Alright, lads. So, lads, what you do for the chain rule is, once again, you treat it very similarly to how you would x to the power 5. So, Mooney, what did you do with the 5? Bring it to the front. What you do with the power? Alright, and you're missing part of it now, aren't you? So what did you do with the missing 1 minus 3x? And once you differentiate it? And then what you do with the minus 3 of the 5? Yeah. That's pretty handy, lads, is it? Right. Now, that's handy. But now we gotta go for phase 2. Alright. Tell you what. You guys are gonna do 8 part 3, alright? And the only thing you have to do is this. I'll start you off. Change the square roots to the power of a half and do exactly what you did in the last question. Bring the power to the front, take 1 away from the power, differentiate the missing part. Okay? And make sure you write down f dash x for the derivative and you'll be sorted. So what have we done so far? We've done 4, 6, 16, now we're doing 7 and parts of 8. Alright guys, take 1 away from the power. Now, differentiate the missing part. So differentiate the x cubed minus 2x and what you get? 3x squared minus 2. Alright, now, presenting this is going to be awkward. We haven't done a thing wrong, that's the answer. But we'd like to present it a bit more appealingly, okay? So, what can I do with this part here? What can I do with that part there? It's a minus power. What can you do with any minus power? Turn it into a fraction. So I'm going to write 1 over x cubed minus 2x to the power of a half. What can I do to anything that's to the power of a half? Write it as a square root instead. We alright? Next thing. Write it as a square root instead, alright? Now, what other number is on the bottom? What other number is the denominator? The 2. Just put the 2 here, because you're multiplying, 2 is on the bottom. Okay? Now, what's the only number left on top? What's the only number left on top, lads? Or the only part left on the top? 3x squared minus 2. Is that alright with you guys? Alrighty. Yo.
So you wouldn't get full marks for
What's the back of the book look like?
it looks like that.
So, next question we're going to try is 9. Now, 9's pretty hardcore, okay? So, we'll do 9 part 2. Now, what type of rule are we using? Is everybody happy we're using the product rule? Okay, so the y dx equals u times the v dx plus phi times the u dx, okay? But there is a catch. See the yellow part? What rule is the yellow part? Chain. So there's a chain in there as well. So what's x squared minus 1, anybody? And v? 3x plus 2 squared. So what do you reckon for that one? What do we do with the 2? Bring it down. And then we take 1 away from the power. So it's 3x plus 2 to the power of 1. The power of 1 doesn't necessarily have to be there. And what do we do with the missing part? The missing 3x plus 2. Differentiate it and we get 3. And then when we multiply this out, 2 times 3 is 6. It's 18x plus 12. Right, and in we go here. And what do we get, lads? Oh God, I'm so tired. X squared minus 1. The v dx is plus phi times the u dx. Oof. What's the u dx? 2x. Okay. Do you know what I actually did? Do you remember I multiplied this out to get 18x plus 12, and it just takes an advanced die? I actually made things harder on myself, and I'll explain why. I'm going to factorize that. See this part here? I'm going to factorize this back into 6 times 3x plus 2. Can anybody tell me why am I going to do that? Does anybody in the class have any idea why I'm going to do that? There's another 3x plus 2 over the other side. So I can factorize out. What can I factorize out both of these? If you want, it's a bit like this. It's a bit like a times 6 times y plus y squared times 2x. See the way there's a y in both of them? See the way there's a y in both of them? I can factorize out the y. See the way there's a 3x plus 2 in both of them? I can factorize out the 3x plus 2 parts. That's what I'm trying to say. I can factorize that out, and it makes the whole multiplication process a lot easier. So, what do we reckon? Or we could just multiply it all out. You could just multiply it all out if you really want. So I'm going to get 3x plus 2. What's left over? 6 into x squared minus 1. I took out one of the 3x plus 2's, didn't I? So what's left here? 2x by 3x plus 2. Alright, let's multiply this out and see what happens. Might make it a bit easier. So 3x plus 2 bracket save yourself a bit of time. That's 6x squared minus 6, isn't it? And that's 6x squared plus 4x. And that's 12x squared plus 4x minus 6. Alright. What way does the back of the book have it? All multiplied out?
No.
What? Has it like that?
No, it just has it like the top of the lines. Or I'm just back from it.
Has it like this?
No, both are.
Here?
Yeah.
Just left it like that? You won't get full marks for that, no. No. I'd either leave it like that, or I'd multiply it all out, which you could have done ages ago if you really wanted. So you could write it out like this as well. So in that case, I disagree with the back of the book. Alright, what's the first one? The 36x cubed, isn't it? And the 36x squared. Also, lads, if you just multiplied it all out up here, to be honest, without doing anything fancy, you would have got there anyway, so that's your choice. Okay. Alright. How would you do 11, lads? Question 11. Quotient rule, but the top part is also a chain. So do that now, would you? And you're doing a oh, and there's something really handy as well, lads. Look at here. After you differentiate it, straight away, anywhere you see an x, do what? Turn to 0. Then you don't have to do any fancy maths. Just once you differentiate it, anywhere you see an x, turn it to 0. And it comes out easily enough.